Hi, my name is Bob, and today I'm going to show you how to build a pretty standard 2-bolt top rope anchor. And this will actually be what's called a slingshot top rope, which means that you are essentially belaying from the ground and your climber is also leading from the ground. So the rope is basically going up from the belayer through the anchor and down to the climber. The way I usually set this up is with something like a double length sling. Here I have a standard Dyneema sling, and I also have 4 locking carabiners. Any locking carabiner will work. This case I have 4 pear-shaped biners, and they seem to work pretty well. They are a little bit bulky and a little heavy, but they do a good job. The way I'm going to start this anchor is I'm going to look at my 2 bolts here, and I am going to put both of these lockers through the bolts. And you can see here in my first example, I have the screw gate so that it would screw down to lock. And that's ideal. And the reason that that's so important is because if you have this anchor up all day and it's vibrating around, and this is shaking, basically what can happen is this locking mechanism can move, and if it moves, most likely gravity will push it down. So if down is locked further, then you're in better shape than in this situation where if it vibrates around all day, the down orientation is actually going to unlock that beater. So what I want to do is just take that and flip that so that this will lock down again. So I have 2 of those lockers on there. The next thing I'm going to do is take my double length Dyneema sling, and I am going to clip it twice. So I'm going to clip it into the first locker, and here into the second locker. At this point, I want to make sure I lock these carabiners. I am going to check this later on at the end of my system, but I do want to make sure that while I'm working with those lockers that I lock them and make sure they're good to go. So now that I have this clipped through both lockers, I am going to just make 2 different loops out of this. So I'm going to basically pull down the slack in between each of these lockers. You can see here where the Dyneema is connected. This is going to kind of be in the way when I try to tie my knot. So I can force that upward. And now that that's up here, it'll stay out of the way. Now that I have this loop built into my system, I can tie a quick knot. One option for this knot is an overhand. So I basically can take the Dyneema, loop around once, make an overhand knot, and this would be my master point. This is a completely strong system, works really well. But since I have a little bit of extra today, I can take this, spin it around, and make a figure 8 here. All right. So now, again, I have this system with the Dyneema is really redundant at this point. You can see that each of these strands is being weighted pretty uniformly, and they're both going down to these 2 strands that are through the knot. So basically one side of this system could fail, and hopefully this never happens, but it could fail and the other side of the system would still work. So that's the point of redundancy. So at this point, I am ready to get some carabiners through my master point. So again, I have 2 more locking carabiners. I can open those up, slide them through. When you're doing this in a perfect setup, you would have these, again, locking in a downward orientation. So that, again, if they vibrate around throughout the day, they're actually just going to get tighter and tighter. The other thing that you can look for to perfect this system is that your gates are opposite and opposed. And what that means is that basically they're both oriented with the gate locking down, and they are opening from opposite sides. This is beneficial when there's something like an obstruction here that could possibly open this gate, that would be a huge catastrophe, because not only does that mean that your gate somehow came open, but also that it rubbed against something. The odds of that happening are very low, but while you're building your anchor, you might as well make it as good as you can. So now that I have these 2 lockers on here, the last part is that I get my climbing rope. And when I'm setting this up, I usually have a climber side of the rope. I'll tie a little figure 8 on that side there. And I have a belayer side of the rope. Now that I have these 2 lockers, I can take the rope, drape it through. I can lock both of those. And now from the ground, my belayer would be over here and belaying my climber as they climb. The things I want to check before I head back to the ground, I want to make sure again that these are locked. I said I was going to double check that. Real important. I'm going to double check these, make sure they're locked. And then at that point, I'm pretty much good to go. Again, I have a system here that is redundant. And the other big thing I look for is just this angle here. The wider this angle gets, the more force that's put on each of these anchors. So ideally, you would have the smallest angle that you can possibly get. When you start getting to 90 degrees, that's when your angle really is getting to an extreme, and you should try to figure out a system to dial that back. And maybe that's extending one of these draws or something like that, or extending one of these with a draw. So there you go. That's a standard 2-bolt anchor system.